Hey, Mark, how are you?
I'm well. I'm doing really good, Nick. How about you?
I'm really great. I'm so excited to have you on the podcast. You've been in the industry for a long time, just as I have. Um, and I think what I've been trying to do with a lot of these podcasts is that um, the you know the community doesn't get to really understand and know a lot of the leaders that are in the community, and so we want to like let's dive into like a little bit of their career journeys, and that provides, I think, such a really wonderful perspective, and it shapes kind of your view of the market. So why don't we start with that? So first of all, welcome. Really glad to have you. And let's start talking about just a little bit about your career background.
Oh, wow. Yeah, it's been a long career. So you can tell by the gray beard.
It looks pretty good.
uh, yeah. So yeah. I've done quite a lot. I mean, my father opened up one of the first computer science departments back in the '50s. So I've actually been exposed. I built my first computer in the '70s. Started coding in the '80s. The other kids, mowed the lawn, and I wrote batch routines for the VAX and things for my
Oh,
dad.
wow. Was it a TRS
I
80?
did uh, no. So the first computer was actually an ELF.
Oh, yeah.
And it was kind of a kit computer. I've had TRS 80s, VIC 20s, Commodore 64s. I had a PET CBM,
Mm,
with the big 8-inch drives, which
yeah.
was really cool because that was 1.2 meg per
Yeah.
disc, and at the time, I thought I was quite cool.
Yeah. Yeah. I had a TRS
I,
80.
I did a
Sorry. I had to inject.
Yeah, no, the TRS 80. Yeah, no, it had the 5 1/4. This was
Yeah.
the PET or the CBM.
Yep.
Um, so I took a little time and I did about 8 years in the military. And then I got out and got back into technology. Um, did a few different things, mainly coding and VMS related. I then transitioned and I got really interested in networking. And I was very fascinated by how all the machines were talking. So, I started, putting the NICs in promiscuous mode and, doing some coding and other things to start looking at the packets and their interactions. And that was kind of my entree into networking. Ended up at Cisco. I was there for 13 or 14 years and did various things, but I think maybe the most relevant here, I did worldwide escalations for the Catalyst 6500. So if you ever had an issue with a 6500 and nobody could figure it out, and they brought in some weird dude with long hair who was really pale because he was in the lab way too much, that was me.
Very cool.
Um, I transitioned
Yeah.
from there to the early Nexus team. So I was actually like the product line manager
Uh-huh.
for NXOS and some of the Nexus 7000,
Yep.
the early data center stuff when we were at Cisco. Um, did that for a while. Got up through FCS, or first customer ship, and then got brought over to Arista with some of the other folks from Cisco. You probably know the
Oh,
crew.
yeah. Yeah. Good. Yeah. Good
Uh,
group. Yeah.
yeah, no, it's a great group, and I was there for about 13 or 14 years, and I did everything there from systems engineering, product management. I ran the support team, the services team, bunch of different stuff.
Yeah.
I branched out in the cybersecurity for a little bit because I was wanting to test the waters there, and then came back into networking at HP Aruba, where I'm currently the data center networking CTO, and we're working on some new really cool things around DPUs. So we could do a whole episode on DPUs. I'm
Yeah.
super excited about their impact on the data center,
Okay.
and that's where I'm at now. So yeah, a lot of words.
Okay. Yeah. Well, all right. So I have to ask a couple of questions. So why, I don't mean this to be in the pejorative whatsoever, but I'm interested in kind of the, going from, computing and writing code, into, service. And one, thank you for your service, by the way, but sometimes you just don't see that, you kind of mostly just see kind of a different track, especially since your dad was like, computer science, back in the 50s. So,
Yeah, so why did I go in the service? So yeah, it's a great question. My parents asked that quite a lot. But no, I really felt the need to serve. I've always been, I always wanted to be in the military. I wanted to. I remember when the Rangers jumped in on Grenada back many moons ago, and I remember as a kid going, "That would be really cool to do." And there's an old saying: "It's better to regret something you did do than something you didn't do."
Mm,
I was still young, and I said, "Hey, look, let's go see the world." And so I joined and went airborne and did all those cool things, and uh, was fortunate to serve with some really great people
yeah.
and got to see a whole different side of the world. And honestly, it, career wise, some people say, well, that set you back, and it might have a little bit, but
Mm,
I honestly think it gave me leadership skills that I otherwise wouldn't have gathered. So
yeah.
it's a great time, and I don't regret it a bit. And I'd encourage you, if
Oh,
you got kids out there that are thinking about it, it's a great place to really grow up and figure life out.
yeah.
So.
It's like really, because like most of, I think what's really interesting about it is that it kind of took you out of, being inside and being really cerebral with computing, and put you into an environment where you're relying upon other people, and responsible, for them, especially in those kinds of. I'm not sure if you were in special forces or what. You don't need to share if you don't want to, but it's like, but the bottom line is that it was just a what a juxtaposition, of experience, and then when you came back into kind of a, back into high tech, is the career path as I follow it.
Right. Yeah. I mean, it was a great opportunity to really kind of explore kind of boundaries as far as, physical and mental boundaries. And I think that's one thing that the military really taught me. And, some of that was some of the schools and some of the other things I did while I was in. But, it gave me a huge degree of self-confidence. Some people might call it arrogance, but I'm
Mm,
very confident in myself, my abilities, physically, and mentally. And it really, solidified things for me. And like you said, I think it also really helped on the leadership side because
yeah.
there's a difference between being in charge of people and really being responsible, not only
Mm,
for for their care, their feeding, if you're in a combat situation, there's things at stake there that are much bigger than did you meet your project deadline.
yeah.
So yeah, no, it was a great experience, and what it also made me realize is, man, that's a hard way of life. I totally respect the guys and the gals out there that can do it for 30 years.
Yeah.
I don't know that I could have, and
Mm.
hence the reason I decided to go back into tech, and I got a nice desk job and a really comfy chair. So.
Well, 8 years is a lot of service, and like I said, thank you for your service. And it's like it's actually one of the regrets that I have in my own career. Was not serving in the military. I was really close when I was 17. I tried to enlist into the Air Force, but my dad, kind of knowing me better than I knew myself, he's like, I don't think you're going to really make it well there. I don't think that's really for you. It's like you don't like you repel when I tell you to mow the lawn. I don't think you're really going to do well with taking orders. So he wouldn't sign the documents. I was underage. I was 17. So I needed his signature. And he was a World War II vet. So he served in the military. And stationed in Italy. But anyway, but no, I think that's fascinating part of your background. Obviously, I didn't know that, and I think it's it adds a great degree of variety in your experience. So then, all right, so great. Then you come back into tech, and about what year is this? Is this like in the 80s, 90s? Had to be in the 90s. It was
So
Cisco. So yeah,
Right. So 90 95.
yeah,
I got out at the end of '95. I was actually a karaoke DJ and a few other things while I was trying to get back into the tech world. And it's a great example of you don't have to be able to sing to do karaoke. So if you haven't done it, you should try it.
I haven't. I should
I quit
try.
drinking a while back, so I stopped doing karaoke because the two were usually related. Uh, but so yeah, I got back. Yeah, yeah, Nick's like, I've tried karaoke, but yeah, I
Yeah.
was drunk. Wait a minute. Um,
I wish those were on video. Those were must have been just so funny. But anyway, so around
uh,
95, just go, but I want to come back to the karaoke thing in a sec. But go
yeah, so yeah, no, I
ahead.
got out at the end of '95. Bounced around a little bit. I really didn't have a great plan. I just knew I was kind of done with the military. And ended up at a company called Q Systems, which is a process control company.
Uh,
And I did just a bunch of miscellaneous things. They kind of gave me a bit of a break, because I'd had a break in my background, but I knew enough to where they said, well, hey, you're pretty good VMS admin. And they needed one. So I did some administrative stuff on their systems. And then I started inside of the company. I started an internet startup where we sold mail servers. It was actually one of the first mail servers that was non-Unix, non-Linux based mail servers called NT Mail.
yeah.
And when I looked at the industry, I said, well, I can continue down the VMS Unix path, and I'm going to compete against guys with 20 plus years experience. Very difficult, and Windows NT at the time was just coming out,
Hmm.
and so I said, "Hey, look, I can have more experience than anyone because I'm here during the beta." And so that's when I discovered this platform called NT Mail. There was a few other DNS servers and things, and I
Hmm.
brought it to my boss and I said, "Hey, look, I think this is a market we could get into, and I know it's not what you normally do, but could we do this?" And he said, "Sure, in your spare time." So we set that up, turned it into a multi-million dollar business, which was fantastic. Kind of gave me a bit of an entrepreneurial uh, side of things, and it really helped me understand networking because even though it was an SMTP server and a DNS server, and there's a few other miscellaneous products, you really got to understand how things really worked on kind of the earlier days of the internet.
Mm.
Um, I took those. I went to Cisco, and I just, I actually, there's a stop in between where I wrote an ERP system for a manufacturing company, um, and then I went to Cisco, and but the
Mm.
Cisco experience was fantastic because it was in the mid to late '90s.
It's a
It
great
was
time.
right during all the really the exciting time. I mean, just so many brilliant people were at Cisco. There
Yeah.
still are, by the way. Like that wasn't a dig
Yeah.
to the people today. But it was a real exciting time when they were growing, and I started out in the TAC. I had it was two or three job offers, but I took the TAC job because I wanted to understand the bits and bytes.
Mm.
I've always been very interested at the very low level. Um, I've always felt like it's like building a pyramid. If you build a really strong base,
Yeah.
it's easy to build a pyramid. If you don't build a strong base, it tips over.
Yeah. Yeah. No. Yeah. A great
Um,
analogy. I love that. But so so I want to hold on to this, but I do want to go back a little bit. So you mentioned something. So a little bit kind of on the pathway to the on the career journey. But you stopped drinking. So, so I recently, I wouldn't say I stopped drinking, but like I don't drink really that much anymore. And it was the Uberman Lab, Andrew Uberman that really kind of got me. My kids were like also, um, just talking about like how alcohol is such a toxin. And, there isn't a benefit, for it other than you get a little looped, and so anyway, so it's been, I don't know, about 6 months or so, on that journey, and I feel so much better. And I'm so envious of you, for like actually doing that back in the '90s. It's like you probably don't even realize how good you feel, now. So I just wanted to kind of like
right.
touch on that.
Yeah, no, I have, and by the way, I quit drinking. It was about 8 years ago. So it was a little after the '90s, but it's been a while. And
Yeah.
the thing I found with drinking for me growing up, just in the generation that I was in, and you and I are similar ages and stuff.
Yeah.
I mean, that's just a way that you interacted socially. I
Yeah.
mean, growing up, everybody smoked, everybody drank,
Yeah.
and that's just normal.
Yeah.
Um, and so for me, my exposure to being social with people was, well, you drink and that's how you're social.
Yeah.
Um, what I realized when I quit drinking, and I quit drinking just because I started looking at the amount I was drinking, and I'm like, this isn't, this has become a hobby. And drinking shouldn't be a hobby. It's like, this is
Eh,
like a way of life,
Yeah.
and I just decided it was time to quit. And to your point, not only do I feel better, but the interesting thing that I found was there's a whole bunch of people that don't drink, or,
Huh.
or they drink very, very little.
Yeah.
And I never knew they existed because I was the guy drinking.
Yeah.
Once I stopped drinking, I found there's this whole social circle of people that like just they don't drink. It's not a big
Yeah.
deal that you do drink, but it's and
Mm.
so I found that really interesting. Outside of the health benefits, is that wow, people can actually socialize without being drunk.
Yeah.
And I know that sounds really silly today,
Um,
but 20 years ago, I mean, that's just the way we socialize, at least in the groups I hung out in.
well, that was the
So,
culture. Yeah, there's no doubt, about that. And yeah, it's so funny. It's like all the folks, who were either drinking very lightly or not at all, were probably just making fun of everybody who was drinking. Because
yeah, that's what I do now.
behavior gets so modified. It's like so crazy. Anyway, so I wanted to touch on that point because I think it's, it's important. I think, just to kind of like, message different kind of habits, especially healthy habits, around health and wellness. But so let's get back into, okay. So you kind of come into Cisco, right? It's the late '90s, which is a fantastic time. It's like, it's around that time I had a company called Strategic Networks. And so I was working with Dan Lynch, who recently just passed away. I think Dan just passed away during the Easter holiday. Um, but Dan, I was helping Dan build Interop, at the time, and he already had it established. He really just brought me on to, actually bring on kind of the more corporate view, where he was kind of really embedded with the IETF, crowd and kind of the academic, folks who were kind of driving TCP/IP and OSI at the time. But it was an amazing time, and I kind of feel like we're in that time right now, with AI. And I don't want to jump into the AI stuff, just yet. But so your experience at Cisco, the one thing that I love about your background is that you were kind of like the ninja warriors, for the 6500, the cat, is that like if something broke, nobody else can fix it. Okay, bring the ninjas in, and that, you were talking about creating that platform, that base. You had to have it there. You had to know everything about that product. And about how really networks worked. Because you saw all the flows going through it. So you know, um, that's really interesting and intriguing. So, any good stories from like that you can share? About like, oh, biggest problem, the most demanding problem. It's like
Well, and yeah, so it's interesting. There's several of them, and some of them I probably shouldn't share.
okay,
But the one that I found maybe most interesting was this was back in the early days of multicast, and
mm,
the big financial institutions were moving from broadcast networks to multicast
yeah,
for all of their trading
trading, yeah,
applications. And at the time when I was at Cisco, I started really looking at multicast in depth, and I became, one of the SMEs on it, mainly because everybody else didn't want to deal with it.
yeah,
So I just became the go-to guy. And again, I encourage anyone who's listening to this is earlier in their career is find a technology that everyone else is shying away from. And embrace it and learn it, and it will really move you further in your career. And so
mm,
because of that multicast background, I got put into a lot of really neat situations. So I was working with a very large bank who no longer exists. We'll just leave it there.
Mm.
And we had just put Catalyst 6500s in their network, and their network was just melting down. I mean, like just absolutely melting down.
Mm.
And I get a call and they said, "Hey, get on a plane. You need to go to New York. These guys are livid." And, and so I packed my bag and I flew and I went up to New York.
Oh, what a
And,
great call to get. Hey, they're livid.
oh, yeah.
Get on the plane and go there. It's like,
Yeah, yeah.
okay,
Well, the
great.
neat thing about being the technical guy is I didn't really have to be political. I could
Yeah,
pretty much just say, "All right, everyone shut up and give me the terminal."
yeah. Mm.
And they backed off. And what I realized was two things: is one, our multicast designs we were using at the time just didn't really work because we had a single rendezvous point, and we were getting this S comma G state throughout the entire network. And so that gave rise to some of these Anycast designs. So for those of you who don't have a multicast background, this is maybe all Greek, but we used a protocol called MSDP, which really
Mm.
wasn't intended to do what we used it for, to start distributing the rendezvous points and push the SGs out to the edge.
Yeah.
And then the core of the network would have these star G entries, and it scaled better. The problem at the bank I was working at was, we did that. We've said, okay, let me reconfigure, and we put these rendezvous points, but we were still melting the network down. I'm like, what is going on?
Mm.
And in the end, what it turned out was the team that was writing their code had discovered multicast.
Uh-huh.
And so they said, this is the neatest thing ever. Let me use multicast. And they started using multicast addresses, even for like unicast apps.
Oh, huh.
And
Go
so
figure.
like it was crazy. And so basically, after we put some patches in to get the network running again, we had to go and educate the team on, like, if it's one-to-one communication,
Yeah.
let's stick with unicast. Multicast is great, but here's the drawbacks. And so the reason I bring it up is it was a great example of, like, it was really fun because, one, we had to come up with a solution on the fly, and this was this MSDP and some of these other things to distribute the state. And the things we did there, we actually used at many of the other financials moving forward. It became the best practice.
Mm.
But the fun part was the social side of it was, somebody in the networking team gave a talk to the coding team about multicast and how cool it was.
Yeah.
And they embraced it, and they went overboard. And but yeah, that was a real fun one. It went on for ever, but we got it working, so that was the good news.
Well, did the trading floor go down?
Oh yeah, everything went down.
Okay.
It was not
Right.
cool.
All right, that is total shit hit to the fan. Oh my god, I don't mean to laugh, but like,
Yeah.
oh my god, yeah, that's like, yeah, a lot of pressure, on to get that thing back up. All right, let's fast forward a little bit. HPE. So tell me about your role, kind of data center CTO. Take it from there.
Sure. Yeah. So I was looking for some new challenges. I had some folks that I knew that were at HP Aruba, and they contacted me and told me about this role, and I got really excited about it. Not, I mean, obviously it's networking, it's my background, it's what I really love to do, but they were really trying to figure out how they can introduce the DPU into networks. And
Yeah.
so for those of you who aren't familiar with DPUs, it's a data processing unit. It's just like a CPU, and you got a GPU, DPU. And the idea of a DPU is just to offload the networking and services tasks.
Mm-hmm.
And the idea here
Offload
was
them
that we
from
should
compute. So offloading them from compute. The DPUs.
exactly.
Yeah.
So
Okay.
exactly.
Yeah.
So we're able to, it's like a smart NIC, but really smart NIC. And because the idea there is your workload should be what's consuming the CPU cycles, not
Right.
the agents and all the stuff.
Yeah.
But introducing those into a network is difficult because first you have to crack open every server. And the reality is, once a server is in a data center, you're not opening the thing. Like, it's closed until they buy a new one.
Yeah.
And then the second one is cost, because they are expensive, and unless you're able to see an appreciable benefit it's difficult to justify the cost. But if you look at the hyperscalers, I knew from my work with the hyperscalers that DPUs really made a difference. If you look at Amazon, they were kind of the first people. They acquired a company called Annapurna.
Mm.
Because they were seeing 20-30% CPU load, network relating CPU
Oh,
load on all their
that's
servers.
huge. Wow. Yeah. Yep.
And so, they immediately get 20% more compute capacity by offloading everything to the DPU. Smart move.
Yeah.
And all the hyperscalers started to move down this path and experiment. And if you look, they've all bought TPU companies and whatnot, or they're engaged. But for the regular enterprise, like we look at things differently. Like
Yeah.
I mean, many times in the enterprise, the network is looked as a cost center, not as an enabler, which is unfortunate because none of the applications work without the network.
Well, for sure. Yeah. It's odd. That thinking kind of varies industry by industry sector, and it's like, like in retail, IT is really expensive since their margins are so small, and I think, I've seen that, thinking kind of permeate mostly in that sector, but not immune from others, but yeah, go figure. But I'm sorry to interrupt. Continue, Mark. I'm enjoying this. So go ahead.
Yeah, no, it's and so and I think to your point, you really have to justify things, and it's hard, it's difficult to justify, breaking open every server. So even if you want to implement DPUs, it's probably a 5-year cycle where as you refresh servers 20% per year,
Yeah.
you just buy them with a DPU, and over 5 years you get there. But that doesn't, but what about all the appliances you have? What about the mainframes, the big old Unix systems, there's so many things out there that are never going to have that in it.
Yeah.
So if you really, what allows the hyperscalers to operate so efficiently, their network so efficiently, is they kind of have a single operating system. They have a single way to distribute policy,
Yeah.
um, and services, and that's enabled by these DPUs. So when they called me up to come over, that's what really attracted me. Is we decided, hey, let's take these DPUs, and instead of sticking them in a server, let's stick them in a top or rack switch.
Oh, yeah.
Now it's super easy to deploy because I've got to put a top or rack switch to connect to compute.
Yeah.
It has embedded DPU, so literally it's just plugging an Ethernet cable in, and it allows me to adopt the technologies over time. So I can say, hey, let's put it in as a regular top or rack. And now let's start to enable services, so I can do firewalling at the TOR.
Mm.
I can do NAT, IPsec, DDoS, server load balancing. And I've got now a unified policy because all of my TORs, I've got the same policy across it regardless of what's connected.
Yeah.
And this idea just intrigued me so much, and I really felt that this is the way the industry is going. And so I decided to come over. Now, my role here is a mixture of go-to-market, so the external facing, as well as the internal facing, because I don't feel that we can build a good product without direct field input.
Yeah.
And I'm not talking about filtered field input. I'm talking about we need to directly involve our customers in our development efforts to make sure we're solving their problems. So
Yeah.
that's really my role here is to help build that data center business. If you think about HPE, I mean, we are data center outside of networking.
Yeah. Yeah.
I mean, we're known for data center.
For sure.
So, the step in the networking, isn't a big leap for us because we already have the networking business. We already know how data centers are built.
Yeah.
So it's really just some features, some functions, some form factors, and really just getting out and evangelizing.
Well, it's a key role. So it's like really at the intersection of kind of customer requirements, customer needs, and then also kind of in that CTO role, like, going back to engineering and project management, and kind of helping prioritize, I think, features, and making sure that, that there's, what engineering is putting in as their priority is kind of making sense of what you're hearing on the customer side of things. It's an important role. A lot of companies will fail because they don't do that well. They'll miss markets. They'll miss market trends, as well. So that's great. So, hopefully that's, a key reason why you're also maybe how ONUG might factor into some of the work that you're doing. And so I know we're just kind of getting started, with you, Mark, and also with HPE. So now that I know that too, I'll make sure like we start to kind of tailor our interactions, around that, also to kind of feed into that funnel that you have. So, okay, I want to so great. So thank you for that. Let's start to think a little bit about, GPUs kind of like fit into this, as well. And I'm kind of thinking I'd like to have a little discussion around the AI activity that's happening right now, especially around AI infrastructure. So I think one thing, so when I think, and you living at that intersection, I'm sure you see not just kind of technical requirements, but you're seeing a lot of the applications that people are deploying and they're thinking about, and so are there any like kind of top AI, business apps that you're seeing, that are kind of resonating and kind of like bubbling up to the top?
Well, when we start talking about AI, I think you've got two different aspects of AI. You've got the applications
Yep.
that leverage AI,
Yep.
right? And then I've got the network and how the network changes
Right.
based on these AI workloads.
Right. Well, I think
And
there's a
and
third
so
one too. So it's how AI is now impacting that infrastructure. So
right.
independent upon the applications. Yeah, and that is actually um, there's a tree there. That kind of goes in two different places. So let's think. So we'll get to like the infrastructure piece. I was just wanted to maybe talk a little bit about the applications piece because I can kind of share like what we've been seeing across the ONU community around kind of AI apps and how they're seeing it coming into like their corporations. So, but you see lots of different companies. So I thought, okay, now let's see if maybe our perspectives jive.
Right. Well, so the power of AI is really incredible. I mean, like what you can do. Like sometimes when I get if I get a little stuck on trying to write a document, I'll say, all right, well, I'll go over to Copilot and say, write an abstract for whatever. And it's not so much I'm using the abstract, but it's a great way to kind of get my brain engaged. So like I use AI on a regular basis, sometimes just to kind of kickstart me and get me pointed in the right direction, which is interesting. And I see, when I've talked to people, I don't think I'm alone in that. I think other people are using it. And I think if you're not, you should try it. I mean, it's built into a lot of applications and it's really powerful. So, just starting there, I think just day to day work, it's like having an assistant that doesn't judge you when you ask stupid questions. And
It does sometimes.
um,
Sorry, I can't answer that question for
so
you.
but so I think that's one. But the other thing that I really see AI playing into, especially as it intersects with the data center,
Yeah,
um, is because it's really my area of expertise, is really around the operations of the data center. Because I mean, if you think about it, everything in the data center or in the networking is we're just kind of waiting. We're waiting for something to happen.
yeah,
And it's my firm belief that where we're at with technology, um, it's not far fetched to say, look, the network should be self architecting, should be self provisioning, it should be self healing, it should be self securing, and it should be doing all of this without human intervention. I
yeah,
mean, I don't. I'm an old CLI jockey, and I'm still very comfortable jumping on a CLI router, BGP, and going to town. Right, there's no problem with that.
yeah,
But honestly, why am I doing that?
mm,
The machine can do it so much faster,
yeah,
so much better, and it can start predicting problems, which I think is really the holy grail when I look at networking and operations is how do I make my operators more effective and how do I make it's not about getting rid of people. It's about helping these people find that needle in the haystack, whether it's operationally, like, hey, this optic is slowly seeing a degraded light level and an increased bit error rate. You should do something.
yeah,
It's a great example of something that's relatively easy to do. that, something like an AI type application, could start figuring out, when I see these five things happening, bad things are going to happen. You need to do something.
Yeah.
Um, and I think that's really where I see the biggest impact. But I still think it's a layer 8 problem. Maybe layer 9, maybe layer 10. Like it's more of a political problem of people having the trust in the system to let the system do what it needs to do. And by the way, that's probably well founded, because like I've had a Tesla since 2013, 2014,
Mm.
and I've been a huge proponent of self-driving. This is going to be
Yeah.
awesome. And I'll tell you what, self-driving has almost killed me at least 3 times. And now like these, I see videos of people like, I'm going to get in the back seat and let it drive.
Yeah.
That's just not, yeah, it's a bad idea.
Really bad idea. Yeah.
Um, So, and after a couple near death experiences, and they usually involve shadows for some reason, shadows
Mm.
really seem to throw the Tesla off, or at
Huh.
least in my experience. Um, it makes you a little gun shy. And so if you take that same thought and you say, well, I'm going to turn my network over to it, I can understand why people would be a little gun shy. But the reality is the networks are too complex. There's too many variables. And then when it comes to security, there's like, the only way you're ever going to get to like you're never going to secure your enterprise. You have to
Mm.
assume you're already breached, and you have to focus at detection.
Yeah.
I mean, obviously prevention is super important, but you have to focus at detection. The only way you're really going to detect it is with something like a powerful MLAI type algorithm that understands normal and can figure things that aren't normal.
Yeah.
And I honestly think it's the only way that we really truly move forward in networking and security is to really embrace this new technology.
Yeah, I'm with you on the whole lifecycle management and the operational impact, that AI may offer. I think so. Let's stay on this for a little bit, but I also want to jump to kind of AI infrastructure, as well, and how that might transform um, data center design and how we're maybe reimagining both kind of network data center networks in wide area, as well. But on the kind of operational, attributes and the value that we're kind of seeing with AI, or the promise there. So that's where, okay, the impact of AI on kind of networking, also impact of AI on security products as well. So I think what I know I've been starting to see is companies starting to offer products that are right now. There's kind of like we're at the first phase of, right, so it's like there are companies that are offering kind of like an LLM to go along with their configuration manager or with their network management to help around with troubleshooting, configuration management, and so forth. And I think all that's really good. But then there's a new breed of companies, not companies, but products that are starting to rethink those products from like the ground up. So what does like an AI router really mean, or an AI firewall, or an AI switch, where you actually have AI into the product itself, or you have sensors that are feeding into like an AI that is actually pulling data from various different parts of that infrastructure. And so if we kind of think through that, and one, Juniper is a good example. It's like you guys just acquired Juniper. I know they're going to be integrated soon. So like they have, it's the kind of native AI, and I think that's what they're getting at. It's like we really kind of built this from the ground up. It's native AI inside these products, and there's a whole slew of other companies that are coming into the marketplace. All the chip manufacturers, whether it's Broadcom, Intel, um, AMD, and others. New generation of chips that are coming into the marketplace that are to enable AI as well. So we're going to, like, in this next 18 to 24 months, the product refresh is going to be freaking amazing. There's going to be new products out, all over. So I think, with that, as I start to think about that, I think in the near term, I think the operational that might be the first value that we're going to look for is okay, operational value, remove the toil that's within the data centers, maybe allow us to respond quicker to anomalistic behavior or signatures, of threats so that we can mitigate them, much quicker. But I think there's also a different relationship that could emerge where the infrastructure that relationship between infrastructure and the applications, where the application is signaling to the network, I need this kind of service for this application or this particular user with this particular role. Maybe that's kind of tied in with policy. But I think then what the infrastructure can deliver back to that application is okay, based upon the policies that we have for this user, this application, we can kind of offer you a path, an end-to-end path that, in essence, has a security posture that correlates with policy. It has a latency. It has a dollar cost, for that connection, for that. So I'm just thinking that the relationship between what we normally would think of infrastructure and applications should change, for the better. And I'm not sure if you're, if you and HP are thinking along those lines, or if there's maybe another branch that you're thinking about.
No, I think you're fairly spot on. Although I think with this, a lot of stuff that you're talking about is going to take a while for it to really be impactful because, once you start talking about doing some of the stuff you're talking about, which is really just like the application or the developer, whatever, signaling the network and saying, hey, look, I need lossless connectivity. I need it to be under whatever microsecond in latency. And I'm going to be sending you X amount of traffic or whatever the variables are. I need these security postures or whatever. And that gets sent into the network, and then a path is provisioned for that application and or that workload. And I definitely think that's where things are going to go, or some variants of that.
Mm-hmm.
I think the problem with that is we're still in this heterogeneous state where I've got different vendors. We all have our own ideas on how this should be done. There aren't any standards out there that really dictate how this is going to be done. Although, if you look at what UEC is doing, they're really looking at like libvirt and like InfiniBand's got what they call verbs,
Yep.
which is kind of what you're talking about.
Yep.
UEC is looking at similar types of constructs. And not exactly what we're talking about, but similar from and so I think the first thing that's going to happen is we're going to all have to sit down and kind of figure out what this means and how we're going to standardize it, because it wouldn't be overly hard for somebody like an HPE or a Cisco to come in and say, we're doing it this way.
Yeah.
But I don't think that's what customers want, because, and that's why groups like ONUG exist, I feel, is that, look, I want to be able to have vendor choice. I want the vendors to compete because that's going to give me the best price. That's going to give me the best product, and it's going to give me the fastest time to market.
And it's going to make the vendors better
so
too.
I think 100%.
Yeah.
100%. I mean, we've got to, and I don't want to compete in an area where I've got 100% lock in, where I'm the only choice in town, because it's just not, anyway. So I think that's actually the hurdle to us getting to where we need to get, is getting the vendors on board to agree on some level of standardization. So I think what you might see is some of this in its earlier phases really taking more of the form of a controller, where I'm signaling the controller. The controller is then provisioning via legacy methods the provisioning of the network or what the security policies or whatever.
It's okay. We like dogs.
I apologize.
No, don't, Mark. Don't worry about it. It's all good.
The only time they bark is when it's right now. So.
Yeah, no, it's all good. Really, we love dogs. We love children. it's all good. Yeah. So, unless you have to go, do you have to go? Run. We can kind of pause.
No. I'm fine.
Okay.
Yeah.
All right. Great.
That's the FedEx guy, I think. So
Yeah. Well, like I said, everything it's all good. So I think one really great point, and actually we've been talking about this. I don't know. It's you're going to see it kind of manifest itself in the spring meeting. But it's all about what do you do with different AIs, and different approaches like to AI, So is there kind of a Uber standard? Is there like a TCP/IP for AI, or is there maybe it's a federated model, like as you mentioned, there's a controller, application signals to the controller. The controller then distributes that to like n different AIs, based upon who's in that infrastructure, and then there's some kind of federation, that happens, between them. But I don't, but you're right. That is kind of a whole question mark, about how this will develop, and maybe that becomes a basis of competition, like whose AI is better, and how you kind of utilize that, to kind of drive customer value. Could be you can see that clearly happening. So yeah, no, I'm totally with you, on that. It's like I think that relationship is going to change, and I think you're also right, that that will be regulated by how fast we're able to do that in a mixed heterogeneous environment, within the infrastructure, and not only just like on-prem, but also off-prem as well. So it's like the cloud providers, now. I think the last time we did some data, it's like um, half of the um, infrastructure that corporations and within ONUG anyway are relying upon, they don't own, right? So it's like so there has to be that federation has got to be not only just across the vendors within on-prem, but also outside, as well. So um,
well, and just to maybe add to that a little bit, the for you to do anything ML or AI wise, you really need massive amounts of data.
mm,
And that data is how it's going to learn and how it's going to make that right interpretation of what's going on. So I've worked with a lot of companies, and there is a bit of even though people are putting things in AWS, Azure, GCP, Oracle, you name the provider, people are still reticent to move some of their network operations and move to a cloud-based management. So, I mean, with, you know,
for
it's
sure.
becoming less of an issue today. I mean, 10 years ago, it was a full non-starter for most large enterprises to do anything off-prem. But I think the only way that this actually works is that you've got all these clouds of information. Like, so say you're running Palo as a firewall, and you're doing Panorama, and they've got a bunch of your data, and then you're using HPE networking, and we've got a bunch of data in our GreenLake cloud platform on server storage and networking, and then you've got five other vendors, and they've got their stores of information. I think one of the first things we're going to have to figure out is how do we start to federate that information, because we don't want to like duplicate it because it's a massive amount of data. But how can we start working together to create federated clouds? So, I could, get an API key or some type of key that, gives me read only access to what you're doing on your security side with your cloud based XDR system, right? And then they have access to some of the data that I have around flows and other things like that. I think that that's something that we need to solve,
Um,
because if we just leave this as pure replication of data, and you're a large enterprise and you're saying, I want everything on prem, what you're going to find is you're going to build two or three massive data centers that do nothing but hold data.
yeah.
And so I think that's something else we've got to look at as we're moving down this path, is how do we start to federate that data? And I think the company that has the most data in the end is going to be the winner here.
Mm,
So I think that's something we've got to solve, and something as an enterprise user, you really have to think about is how is all this going to come together? Because without good data, MLAI is trash.
Yeah.
Garbage in, garbage out.
Yeah, well, that's a really interesting point. We are starting to see some intercompany or inter-architecture development between companies, like Microsoft Azure and Oracle is a good example of that. So like if you kind of are using particular Azure applications, but all your data is within Oracle. The work that they're doing now is that okay, well, how do those applications in Azure have access to the data? That's within Oracle, and maybe some of the data is also on-prem as well. And so it's we're kind of early on in this, but I think the whole AI era will also drive um, whether it's federated or whether it's more of a intercompany architecture. And where I think that's really being driven by consumer. I know we've been kind of advocating for parts of that, within ONUG, as well, and we can probably do a lot more of that. So I'm with you, on that. I think that's a really great salient point. I know we're getting a little bit, short on time, but I want to like hop on to the other tree in this whole AI infrastructure piece. And so you have NVIDIA with their pods, and we have kind of like clusters where obviously we have GPU, CPU, we have the fabric, which is InfiniBand. That's there's a lot of work being done to kind of provide an option there for on Ethernet. And so so there's a scaling out of that where kind of 8 GPUs go to like 16. Like the numbers I'm starting to see, it's like 32,000. Azure is now talking about how do I scale that to like 1 million. So like that's obviously massive scale. Um, but then that's on the GPU and the fabric behind it. And then on front of that, that's, the DPUs, the RDMA, and then also to scale it up is like networking, right? So how do you, like, you can't have, I guess you can, but it's like, if you're going that big, and maybe that's where the market goes in the next, kind of cycle, in 2030 or so, is that you're not going to have one data center. You're going to have multiple different data centers, and you're going to have to network them. And so over the wide area. So I think, maybe the question, Mark, is the design center that I just, articulated is kind of an NVIDIA data center. It's not and it's becoming really the de facto, standard. There's $3 trillion in that architecture, and so maybe the question is that, and I know there's a lot of companies looking to democratize that, and to like, add value to that and to like make it more multi-vendor and try to eliminate um, the the supply chain constraints, especially around GPUs. And so this is kind of the question: is that is this kind of like the next generation data center design? Like enterprises never like they'll hold on to legacy for a really long time, but like even though that architecture is being built for AI and AI workloads, I guess the question is, if you can kind of reduce the power requirement, reduce the costs and capital costs associated with that through democratization and some standardization, does that become the way that we actually build data centers now? So,
I definitely think it will heavily influence it. And if you look, we've kind of been going down this path already. If you think about the three-tier, core distribution access design, Arista kind of came into the market and really popularized the clause design, the two-tier
yeah.
design, which, by the way, was around before Arista, but that they were the ones that really popularized that. And if you think about it, the reason you could get rid of that middle tier was just based on densities, right? The number of integrated circuits, the number of ICs I can put on on an ASIC, is following Moore's law now,
Hmm.
where it wasn't before, and that allows us to get the port count we had, and that allows us to then collapse things down into two tier. If you look at the current ASICs and then the next gen ASIC, so everybody right now has an 800 gig, 64 by 800 gig.
Hmm.
That's now the new standard for ASICs. but they're rapidly working on 1.6 terabit per port.
Right. Hmm.
And that's going to come out, and that'll be 64 by 1.6 terabit.
Hmm.
That's scary. I still remember when 1 gig came out, and we were high fiving each other, and I used to use 10 meg half as congestion control, as a poor man's QoS. And now it's, now the speeds are just incredible. I mean, just to conceptualize this, let me give you a little fun fact. If I'm not mistaken, a million seconds is about 11 minutes.
Hmm. Oh,
A billion seconds is like 20 years. I mean, like, and don't quote me on that. Like that those aren't like but that's the scale numbers we're talking about when you go from megabits to
yeah.
gigabits. It's and now I'm able to express PCI bus speeds over the network. And as soon as I can start to express PCI bus speeds over the network,
Yeah.
where my memory is located, where my disks are located, where my GPUs are located, all those things are irrelevant anymore. And now I can really think about re-architecting the way that I do things. So yes, I think that you'll see some knock-on effects, because when I look at an AI data center, what's required is I want lossless, and I want end-to-end congestion control starting at the host.
Yeah.
And it has to kind of start at the host. Otherwise, I'm going to get congestion problems. NVIDIA is ahead of the game only because they are the only InfiniBand vendor, and currently they are the de facto standard in the GPU market.
Yeah.
That's the only reason that they're kind of the standard. But I don't think the market wants another Cisco. And again, I'm not picking on Cisco. I was there during the glory days. But what happens when you get one vendor that controls the entire ecosystem?
Yeah.
You get really high
Yeah.
prices, and that's, I think, we are seeing a flood of other vendors, AMD, Intel. There's a bunch of startups in the GPU space. And on the networking side, we've got Ultra Ethernet Consortium, UEC, coming out, that's really trying to standardize and say, look, we can make Ethernet on par or better
Mm.
than InfiniBand. And by the way, if you look at HPE, our Cray systems, which are supercomputers, we power the biggest exascale. I think 8 of the top 10 exascale computers are powered by our Cray systems, and we have a Ethernet fabric called Slingshot
Yeah.
that powers those. That gets much better performance if you put it up against an InfiniBand network, like for like, speed for speed. But that's a Dragonfly design, which is very different than the 2-tier designs.
Yeah.
So I'm using a lot of words here, but I think what you'll see is standardization across the board, because that's really what the customers want. And you'll see this competition, and you'll see these end-to-end congestion control mechanisms come in. And it will fundamentally change the way we do things. But keep in mind, when I think about an AI workload, it's kind of one application. So I've got one data center that's kind of focused at one application.
Mm.
That's the complete antithesis of a work of today, because now I've got thousands of workloads that all work together
Yeah.
to do different things.
Yeah.
So I think the design patterns and the principles and the protocols are useful, but I don't know that you'll anytime soon see a data center that, well, I'm doing AI now, and 5 minutes later I'm going to go do something else. But I do think that the AI, what we're doing in this space, will benefit networking, because it's going to make it faster, it's going to make it cheaper, it's going to make it more powerful.
Yeah.
And in the end, that's good for everybody.
Yeah, and smarter. All right, so it's going to be
Right.
faster, better, and cheaper. Right? Hey, Mark.
Well, that's the one thing that, if you bought a TV, as I was cleaning out the storage thing that I had, and we sold a house, we bought a new house, you have all this stuff that you had. And I had this 27-inch TV that I had bought back when I was in the military, that was stashed down in the basement.
Wow.
The big tube TVs weighed like 300 pounds.
So heavy.
27-inch,
Yeah.
top of the line.
Yeah.
And I think that thing cost me $500-600 back in the day, many moons ago. And if you look at a TV now, I can buy a 65-inch TV on Black Friday, 4K resolution, for $499.
Yeah.
And so in a 27-inch, I can buy it for $50 on the right day. So you actually see, I think, deflation in the technology space and I think, which is interesting because you see inflation everywhere else, but in technology, we seem to drive prices
I
down.
know it's a beautiful
Um,
thing. It's the industry that keeps on giving. You know.
exactly. Now we just need to figure out how to drive down sports cars like that because I really like sports cars, but I have exotic tastes and I don't have the budget to afford them.
Yeah, that's a little bit more of an exclusive marketplace, you know. Hey, Mark, this has really been so much fun. Really enjoyed it. Thanks so much for sharing, especially your career journey and and your health and wellness, habits, as well. So thanks so much, and thank you everyone for plugging in.
Thank you, Nick, and thanks everybody. Take care.
Awesome.